Hello, my name is Jamil Sunna and I will be explaining the fourth topic. And thank you.
Differential pair with active load. Previously we have learned that this circuit here would give us a gain of GM R7, where R7 used to be R out parallel with RD. Our goal is to have V output between this node and the ground, and not between two nodes. This is called a single-ended output. And in this circuit, if we kept everything as is, the gain will be half the original gain that we used to have. That is half GMRD with parallel with R out. The reason for this is that we are using only V out and V out or V out 2 in our calculations. So we will have to find a way that will keep the gain as is and not to be reduced to the half of it. Having a closer look on the circuit and to fully understand why we lose half the gain when we use the single-ended circuit. Notice that R7 is not affected. However, GM is affected here. Here we have V out equal negative RD parallel with R out, GM divided by 2 multiplied with V input differential. And V output 2 is the positive of RD parallel with R out, GM over 2 V input differential. So when we calculated the V output differential, which is V output 2 negative of V output 1, then we subtract this from this, giving us the negative of this, which is positive, and GM2 plus GM2 give us the full gain GM, which is big GM. As written here, in this case GM equal GM. However, in single-ended circuit, GM equal half of GM, small GM, due to the fact that we take only V out or V output 2 in our calculations. So now we have to put a circuit, and we still don't know what it is, on the load side of this circuit that could make this current, which is GM over 2 multiplied with VD, into this side of the circuit, so that the total current, in this case I out, going into this direction will equal to GM2, GM divided by 2 plus GM divided by 2 V input differential, so that we have the full gain, which is GM VI input differential. In this case, GM will equal to small gm. Given that this current was copied from here, and this current is from this circuit, this part of the circuit. In order to find the GM, we will have that I out divided by V differential, input differential, when the V out is grounded, as shown in this circuit. To start with, to make life easier and our calculation more smoother, we'll have to focus on R4 and R2. Notice that R4 is connected between the ground, which is V out, and the other side is the ground here. And when there is an impedance between two grounded, it's neglected and can be safely removed from the circuit. Also, R2 is connected between V out, which is grounded, and this point here, which is also grounded, and can be safely removed from our calculations. Going to the left side of the circuit, we're having R1 and R3. Notice that both R1 and R3 are connected to one side at this node here, at this point here. The other point of R1 is connected to ground. Also R3 is connected to ground. So we can say that R1 and R3, RO1 and RO3 are in parallel. Using current mirror concept, we will transfer this current here with this direction into this current here with this direction. And to do so, we have to multiply this current with a factor, which in this case will be V gate source 4 multiplied by GM4. The value of V gate source is R Thevenin multiplied by this current. R Thevenin in this case will be R out 1 multiplied by parallel to R out 3 parallel to 1 over GM3 due to the diode connection over here. Never forgetting to multiply it with the current, which is GM over 2 V input differential. So this current, which is I out, will equal to the sum of this current and the sum of this current that we have found here. So I out will equal negative, the negative because it is opposes the direction of both currents, GM over 2 V input differential, this value here, plus the value from here, which is GM over 2 V input differential multiplied by GM4 multiplied by R1 parallel with R3 parallel with 1 over GM3. To make our calculation more simpler, notice that 1 over GM3 is much less in value than R output 1 and R output 3. So from this value here, all what we have is 1 over GM3. Given that GM3 equal GM4, these two values have the same value. Quantities have the same values, so can be removed. And all what we can have here is I out equal negative sign of GM over 2 plus GM over 2 with V input differential as a common value between both GM over 2 and GM over 2. Resulting that I out will equal negative of GM V input differential, and notice that GM in this case will equal GM small. At this point of the analysis, we're gonna discuss the R Thevenin calculations. Using the definition of R Thevenin, which is V test over I test, when V input equal to 0, and when V input equal to 0, we mean that it is grounded, like here and here, shown on the figure. Notice that when we grounded the V input, this point P is no longer an AC ground. Also notice that this current source is now an open circuit because we are dealing with a small signal analysis. Now, as you can notice that RO4 is connected between this node and the ground. So for easier calculations, we're gonna move it to this point here. I only changed its position. And now I test will equal to this current here and this current going up there. For our analysis, we're interested in the current going down, which is gonna be I2. This I2 will split to this RO2 and this M2 and recollect it at this point, which is I2. This current will also split here and reconnect it at this point. And through our previous analysis, we have found out this current is going to be copied to this point here using the current mirror analysis. So as you can see and figure that I test is now equal to 2I2, which is equal to 2V2. So that I2 equal to V test over R2. And now we have to do is to find R2, which is looking from here and making it parallel with RO4 to find the total R7. To calculate R2, it is gonna be RO2 plus 1 over GM with 1 plus RO2 plus GM2. Now we assume that RO2 GM2 is greater than 1. So this one can be neglected. So RO2 equal 1 over GM RO2 GM, which is equal to 2 RO2. Back to this equation, we can find out that I test will equal 2V2 over 2 RO2, which is equal to V2 over I2 will equal RO2. So R7 in total will equal RO4 that we have moved here parallel with RO2. And we're almost done. All what we have to do is finding the polarity of the gain. We can find out that if this terminal is positive, so this side this side will be out of phase, which implies that this side will be in phase with the VID over 2, so that the polarity is positive in this case. To a related topic, we're gonna talk about the common mode gain. In the common mode gain, this point P is no longer a virtual ground, because this point it changes with whenever VICM changes. When this node increases, this node also increases, which is affect this point. So we're gonna use a topic and a trick we have learned earlier, which is, and a relative topic is a common mode gain for this circuit. Notice that this circuit at point P is not an AC ground as before, because when VI increases here, it also increases here. So we can say that this point is an AC ground. Notice that I2 equal to I1, which is I drain for the MOSFET, and that the current passing through the RSS is I1 plus I2, because the current source is now an open circuit because we are dealing with small signal analysis again. So we're gonna use the trick we have learned earlier in current mirror, which is 2RSS will be split into both sides. We're gonna find the A gain common mode, which is equal V output divided by V input common mode, which is also equal to the GMR7. Before we go on, we're gonna assume that R1 and R4 are negligible. Also that GM1 will equal GM2 will equal GM, and R output 1 will equal R output 2 will equal R out, and R output 3 will equal R output 4. So now we have shortened the output. We're gonna calculate the current that the output will equal. Notice that I2 will equal GM effective V input common mode, and GM effective will equal GM over 1 plus 2 RSS V input, and I4 will equal this current here multiplied by the factor GM4 V gate source 4, and the V gate source will equal R output 3 parallel with 1 over GM3 multiplied by this current here, GM effective VICM. Remembering that we have neglected the value of R1. Now we can see that I output will equal I output 2 minus I output 4, which has come from the sign convention that I output 4 goes down there, I output goes downward, and I output will equal this in this direction. Moving on, I output will equal this value here, which is GM effective VICM, which is the value of I2, negative of GM parallel with R output 3 1 over GM3 GM effective VICM, which is the value of I4. Doing some math multiplication and we'll finally get this value that GM will equal 1 plus R output 3 GM3 the minus of GM4 R4 divided by R output 3 GM3 plus 1. So this term cancel with this term because we have already said that GM3 will equal GM4 and R output 3 is the same in both sides. So that GM will equal GM effective divided by 1 plus R output 3 GM3. And to calculate R7, we're gonna grounding the input and applying V test over I test to find its value. So as you can see that this value here is parallel with this value here. So when we're looking upward, we're gonna see R output 4, and when looking downward, we're gonna see all these values. Assuming that these values is much greater than R output 4, and R output 4 is less than this value, we're gonna approximately have the R output 4 for R7, and ACM will equal GM R7, and just substituting our values here, we're gonna get that the gain will equal 1 over 2 RSS multiplied by GM3. One last note before ending up, we have found this value and this value earlier in this video, so you want to calculate the value of the common mode rejection ratio, which will equal to the 20 log of AM divided by ACM. Notice that R2 and R1 are equal, so we're gonna say that its value is R output divided by 2. So this value will approximately equal 20 log GMR out multiplied by GM3 RSS. Thanks for watching and see you in next videos.